In this video, we're going to look at 4 more examples of mutually exclusive versus inclusive events. Alright, so let's get started. What is the probability of choosing a card from a deck of cards that is a club or a 10? So think of a club or a 10. Can those two things occur at the same time? Yes. So they are not mutually exclusive. And when they are not mutually exclusive, we're going to need to subtract the overlap of the two things. So the probability of choosing a club or a 10 is the probability of choosing a club plus the probability of choosing a 10 minus the probability of the club that is a 10, so it would fall in both categories. So the probability a card is a club is 13 out of 52. The probability of getting a 10 would be 4 out of 52. And then we have one card that is both a club and a 10. So we need to subtract that card. Let me just put all that together. So 13 plus 4 minus 1 would be 16 out of 52. And so then we could reduce that number if we needed to, or get a percent. What is the probability of choosing a number from 1 to 10 that is less than 5 or odd? So the first thing you want to think about is, can it be both? So we have a number between 1 and 10. So 1, 2, 3. Let me fix that. 3, 4, 5, 6, 7, 8, 9, 10 is our sample space. All right. And are there numbers that are less than 5 and odd at the same time? So the probability of numbers less than 5 would be these 4 numbers. And then we have the 1 and the 3 that are also odd and less than 4. So these are not mutually exclusive. They can occur at the same time. So we would need to use that same formula we did in example 1. We need to say the probability of less than 5 plus the probability of odd minus the probability that it is both. All right. The probability it is less than 5 for 4 out of 10 numbers. The probability it's odd is 5 out of 10. And then there were 2 numbers that fit both categories out of the 10 numbers. So 4 plus 5 minus 2 would be 7 out of 10, which would equal 70% if we needed it. Alright, so 2 more examples. A bag contains 26 tiles with a letter on each. 1 tile for each letter of the alphabet. What is the probability of reaching into the bag and randomly choosing a tile with one of the first 10 letters of the alphabet on it, or randomly choosing a tile with a vowel on it? Alright, so let's list out the first 10 letters of the alphabet. So we have A, B, C, D, E, F, G, H, I, J is our sample space. So are there letters that are also vowels that are in those first 10 letters of the alphabet? So we would say A, E, and I are vowels, and they are also in the first 10 letters of the alphabet. So these two events would not be mutually exclusive, or we could call them inclusive. So not mutually exclusive and inclusive are the same idea. And then we need to figure out our probability. So we would have the probability that it's one of those first 10 letters of the alphabet, plus the probability that it is a vowel, minus the probability that it is both of those things. Alright, so the probability that it's one of those first 10 letters of the alphabet would be 10 out of 26. The probability that it's a vowel, so think of all of your vowels. We have A, E, I, O, and U. So those are 5 letters that are vowels out of 26, minus the probability that it was both. So that was the A, the E, and the I. So that was 3 out of 26. All right, so 10 plus 5. And then whatever the percentage is. A bag contains 26 tiles with a letter on each tile. and each one is a letter of the alphabet. What is the probability of reaching into the bag and randomly choosing a tile with one of the last 5 letters of the alphabet, or randomly choosing a tile with a vowel on it? All right, so let's think of this situation. So if we have the last 5 letters of the alphabet, it's V, W, X, Y, and Z. So our vowels are A, E, I, O, and U. Notice none of those overlap. So these are going to be mutually exclusive events. They do not happen at the same time, and you can't have a letter that would be both one of the last 5 letters of the alphabet and a vowel. Okay, so we need to calculate the probability. That means we just need the probability that it's one of those last 5 letters plus the probability that it's a vowel. But there's no overlap, so we don't need to subtract it. All right, so there's 5 letters that are the last 5 letters of the alphabet out of 26 total, plus the probability that it's a vowel, which is also 5 out of 26. So then we just get 10 out of 26, which is 5 out of 13, and then whatever that decimal would be. I'm just trying to save some time, but you could always type that straight in your calculator and figure it out. Okay, so that's it for the mutually exclusive and inclusive example.